Hi everyone, myself Rekha, Assistant Professor, Department of Mathematics. Today we are going to see about the topic regular falsi method in the course Computation Mathematics. This regular falsi method is one of the numerical method to solve the algebraic equation and transcendental equation. For example, if you want to solve x square minus x minus 1 or else x minus cos theta likes log x, we can solve using the regular falsi method. So first we can see what is meant by regular falsi method. So regular falsi method is also known as false position method. It have a certain algorithm. It is similar to the bisection method. This method is a particular case determining the roots and continuous function, and it gives an accuracy and computation efficiency in various mathematical and engineering application. Now we are going to introduce the regular falsi method. It is one of the iterative technique for finding the roots of the function to locate the roots and more accurately than the simple method, especially for the nonlinear equation. So we have a two initial guess bracketing the roots referring to an linear approximation. So already in the bisection method we have the formula x naught equal to a plus b by 2, but for the regular falsi method we can adopt a method that is nothing but a into f of b minus b into f of a by f of b minus f of a. So we have the certain algorithm. First of all we have to find the 2 points of the equation a and b, and next we have to find f of a and f of b. If f of a and f of b are of an opposite sign, then we can go with the calculation the roots using the formula a into f of b minus b into f of a by f of b minus f of a, and we have to update the intervals brackets. Then we have to iterate the process and repeat the process until we will get a answer. And if you compare to the regular bisection method, it is an advantages of the regular falsi. It is an fastly converges compared to the bisection method, and it is a straightforward to implement with the basic calculation and applicable to a wide range of continuous function with the appropriate initial guess. So this is the main steps of the regular falsi method, and the limitation of the method is nothing but we can stagnate the issues and the method may suffer from the updates produced into no change and dependence on the initial guess and not always optimal. So just I will give one example. For example, x square minus x minus 1, if you want to solve using the regular falsi method, means first of all we have to substitute that a into f of b minus b into f of a. A is nothing but if we consider 1, b is considered as 2, means f of a is nothing but f of 1, f of b is nothing but f of 2. So f of 1 is negative and f of b is positive, means the root lies between 1 and 2. So the you have to apply like this: 1 into f of 2 minus 2 into f of 1 by f of 2 minus f of 1. So suppose if we got the value as 1.5, again we have to check it is for 1.5. So for 1.5 it may be a negative value, means again we can root lies between 2 and next 1.5. Now the smallest value here we have to take. Here the smallest value is 1.5 as a and largest value as b 2. So a into f of b minus b into f of a by f of b minus f of a. So again we have to apply that 1.5 into f of 2 minus 2 into f of 1.5 divided by f of 2 minus f of 1.5. So we will get the next value is, for example, if 1.75. Then again we have to proceed in the same case. We have to proceed in the proceed the values until when the value get convergence. So the bisection method, if we go for it, means x naught equal to a plus b by 2, but in regular falsi method the iteration process is very less compared to the bisection method. So how will you find the convergent means? For example, if the first iteration you got the value is 1.5, the second iteration if you got the value as 1.75, and the third iteration if you got the value as 2.75, and the next value is 2.78, means then the value get convergence. So 2.75 and 2.78 the more or less same, so we can conclude that the regular falsi method the value is same. So the conversion value is answer is 2.78. So like that we can convergence quickly. So this is the conclusion. This is a more valuable tool we are offering, and it is useful for finding the numerical methods. So next class we will see the bisection method and also Newton-Raphson method. Thank you.